Welcome back to Math 133, College Algebra for Business. Today I'd like to talk to you a little bit about radicals, especially how we deal with fractions underneath the radical. Here is an example from the e-text that we're working with in class. I suggest you solve it in a slightly different way than the one presented by the e-text, though. All right, the first thing I would do is simplify the fraction that is under the radical. 4 goes into 4 one time, 4 goes into 8 two times, so that's going to give me the fifth root of, and I'm going to take that negative, because I didn't deal with that yet. I'm going to put it by itself inside parentheses, and then I'm going to have x to the sixth, but I'm going to rewrite that as x to the fifth because I'm looking for fifth roots of fifth powers wherever I can find them. Then in the denominator, I have 2y squared. Okay, and now I'm going to break those into two separate radicals. One in the numerator, my negative 1, x to the fifth times x, over the fifth root of 2y squared. Okay, now looking at my numerator, I have a negative 1, and I'm taking an odd root of that negative 1. Any odd root of negative 1 is equal to negative 1, or just a negative. And then I have my x to the fifth root of that. I can bring out as x. Fifth root of x to the fifth is x. But then I still have a fifth root of x. Can't pull that last x right there out. It must remain where it is. Okay, and in the denominator, I still have the fifth root of 2y squared. So now I need to multiply my denominator by something that will give me fifth powers underneath that fifth root. So according to my properties of radicals, I can multiply this whole thing by the fifth root of something that will give me fifth powers underneath. My 2 in my original fraction there has a power of 1, so I'm going to have to multiply that by 2 to the fourth power to get me 2 to the fifth power. And then I'm going to multiply my y squared by y cubed. Now, if I multiply the denominator by something in order not to change the worth of that fraction, don't want to change the value, I have to multiply by the same thing in the numerator. So this will give me negative x, and then I'm multiplying by the same root, so I can put all of that under 1/5 root, 1/5 radical. All right, that'll give me 2 to the fourth x y cubed. And in the denominator, I'm going to have the fifth root of 2 to the first times 2 to the fourth, or 2 to the fifth, and y squared times y cubed will give me y to the fifth. That means I have a fifth power underneath the fifth root. That 2 can come out. Fifth power of y under a fifth root means the y can come out also. So I now have, let me put it over here, negative x to the times the fifth root of 2 to the fourth is 16 x y cubed over 2y. And that's it. I cannot simplify any further. For this problem, my method did not seem to be all that much easier than the e-text method, but let's take a look at another problem. Let's take a look at 150. Let's just take a square root of this, and let's put that over the square root of 21. Okay. Now, to do it the way suggested by the e-text, we would immediately, move to taking the square root of 21 and multiplying it by the square root of 21, so we would get a perfect square, being 21 squared, underneath the square root. And we would multiply by the same thing in the numerator. So that gives us pretty easily 21 in the denominator. But whoa, 150 times 21? Well, that's going to give us the square root of 3,150. And can this be simplified? Well, I'll go ahead and tell you that it can, but you're going to be working a while to figure out what perfect squares are factors of 3,150, so you can simplify that radical and then perhaps simplify the fraction. Instead of doing it that way, let's just get rid of this. The properties of radicals tell us that we can take those two radicals, the one in the numerator and the denominator, and because they are both square roots, we can write one big square root with the numerator and the denominator inside. And now that we've done that, it's a little bit easier to factor 150 and 21. Let's see, if we draw a factor tree, that's like 15 times 10. So we get 3 times 5, and 10 is 2 times 5. Okay, that's completely factored. 21 we factor into 3 and 7. Oh, and look, right there. We have a common factor of 3, so we can reduce that fraction first. That will give us 3 goes into 150. Let's see, 5 times 5 is 25, times 2 is 50. Or you can just say 150 divided by 3 is 50. And 21 divided by 3 is 7. So what I've done is I've canceled that 3 out of there. Okay? And now what I need to do is get rid of that denominator underneath the radical. I'm going to do that. Let's keep it the same method by splitting it apart into two separate radicals again, and then multiplying by the square root of 7 in the denominator and in the numerator. I do not want to change the value of my fraction, so I multiply by 1 in the form of square root of 7 over square root of 7. That's going to give me the square root of 50 times 7 in the numerator, and in the denominator, the square root of 7 times 7, or you already know that that is 7. And then in the numerator, we have the square root of 50 times 7. Now, I left it like that because 50 is a pretty big number. There may be a perfect square inside of there. And let me just move some things out of the way. Okay, there I have factored 50 into 25 times 2, and that's still multiplied by 7. If you really want to see this specifically, 25 is equal to 5 squared. Therefore, I have a square root of a squared term, so the base can come outside of the radical. So I'm going to have 5 times the square root of 2 is not a perfect square, 7 is not a perfect square, so I can say, well, 2 times 7 is 14, and I have 7 in the denominator. Be careful. It's tempting to say, oh, there's 1 7 there, and there are 2 there, and I can cancel, but you cannot. This 14, and thus the 7 that's up there, is stuck inside the radical, while this one is outside of a radical. They will not cancel. That is your final answer. 5 times the square root of 14 divided by 7. So what I'm saying is simplify fractions, simplify signs, do everything you can to make an easier problem before you start attacking the radicals. Okay? Take it easy on yourself, and I will see you in class.